Okay, so the rest of the evening and afternoon, you are expected to work in your groups and answering all the 8 questions. But there was a request to sort of give a little bit of an overview and a recap of what we've been talking about. And so I decided to create a new, very short presentation on what I'm going to call survival analysis. I should have called it simple and complications, because we started yesterday with simple and we've been progressively complicating. But I will start with the complications. And so I'm taking a hypothetical made-up example that we have. Oh, I didn't put it. That's okay. I can do it by hand. So we have 4 patients in intervention arm A and 4 patients B. Okay. And what are we interested in? Time to some event. And I give you an example in the HIV field, and I give you an example in this cardiovascular field. These apply in multiple fields, where the outcome of interest may be particular to the disease that you're studying. So HIV death may be time to HIV death is what you're interested in, or time to CVD death. But you may have competing risks, which is death from other causes than the one that you're interested in. You also may have other clinical events that are occurring that may alter the risk, but that you may be interested in. So you may have, for example, time to an opportunistic infection of some type, or a cardiovascular event of some type. And today, we were talking about you have now another process, some biomarker that is related to that particular event, time to event that you're interested in. So you can have CD4 or troponin or NT-proBNP or whatever in cardiovascular, something or other. Okay? And the complication that we had was that we're interested in all of these things. That's the complication. If we had a simple situation, you're only interested in time to some event like HIV death or CVD death, and you did not have competing risks, so nobody died of something else, and you were not interested in having other events that are non-fatal, you just ignore them, then it's simple, and you don't care about other biomarkers. That's is the standard simple model of time to an event. Okay? The complications come because we have these other things that we would like to study as well. Okay? So just wanted to remind you that for the standard time to an event analysis, so standard simple survival analysis, that's what the Kaplan-Meier curve does, for example, and that's it. That's what the log rank statistic does. That's it. That's what a Cox model does with no covariables also. Okay, so that's what we did yesterday early morning when we don't want to account for the things that complicate our analysis. But today we complicated things because we admitted that we're interested in these other things, right? We admitted yesterday that we were interested in recurrent events. Why are we interested in recurrent events? Because it gives us more power, and therefore we think we want to do that. But we may have also other covariables that are exogenous. We have baseline fixed covariables as well. And today, this afternoon, we included time-dependent endogenous covariables. So I'm using these keys. The X's are the deaths, whether it's the the red one is the one you're interested in, and the blue one is the competing risk. We have the recurrent other outcomes as a triangle, and then the measurement of some biomarker. So what do we have? Let's take it a little bit complicated. We have these 4 people in A and 4 people in B. But what is our research question? Can somebody think what is our research question here? Time to death, time to recurrent events. None of those are correct. Comparing the time to death, comparing between what and what? We're interested in comparing what is the effect of the intervention on time to the event of interest. Keep that in the back of your mind. Always interested in that thing. That's your entire reason for doing this, is to compare the effect of intervention on time to your event of interest. So now when you have, if I look at that and I'm ignoring everything else, what do I have? Well, I have the event of interest occurs in 2 people here. It occurs in 2 people here. There's no difference, but the time to it. It's not the occurrence that I'm interested in. It's the time to that. Here, it occurs early, and here these 2 occur a little bit late, and this one is late. So which is better, A or B? It looks like maybe B is better because these are occurring later. But wait a second, this person had a competing risk that precluded me from getting that death. So now I want to deal with the competing events. So we deal with the competing events, but we're still interested in the effect of intervention on time to the event of interest. I don't care about the competing event. It's a bother, it's a nuisance that I have to deal with. Then we have these other things that are there, other events that are occurring. So now, why am I interested in those? Usually, people are interested in those just because they will get more power. Still, the primary interest is of the primary outcome. And so now you have recurrent things, other things that are in the picture. But there's 1, 2, 3, 4, 5 there. 1, 2, 3, 4. So that one is worse than this because they're occurring more and they're occurring earlier than these. So now, do I want to incorporate that in helping me study the time to the event of interest? So now, but now what we're doing, what we tended to do is we say all of these are bad things, and we give them the same weight. So whether this is a stroke or an MI, for simplicity, we consider them to be, this is an opportunistic infection of one type versus another one. We just say, okay, let's just treat them as any opportunistic infection. And now we sort of slightly change our hypothesis. Now it's time to the occurrence of any of these events. So now my event of interest is not just the death, or I see death as another one of these clinical events. So now I will have, for this one, I'll have time for this, and time for this, and time for this, and time for that. So now our data set also changes. Data structure was 4 observations or per arm. So I had 8 lines in my data set. Now, what I'm going to have is more lines. I have 1 line from here to here, and another line from here to here. I have here to here, and here to here. And I have here to here, there, 1 line here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 observations in the data set. I have to rearrange the data set that way. And I have to tell them that the observations, the first three are from this person. They're correlated within that person. And those next three are from this other person. They're correlated with that person. The other one, two are that. This one is one. I have to structure the data set differently. That takes time and effort. And now I'm enriching my information with more data. Then comes what? Next complication, the one we talked about today. Oh no, first, when we analyze it, we have to sort of push them all back down to zero. So I just slid everything down. And what we had today is that, oh, we are measuring CD4 at certain time points. We schedule measurement at month 3, at month 8, at month 12, at month 24. These are scheduled CD4 counts. Now, some people came early, some people came late, some people didn't come at all for this. And some people missed in the middle, some people dropped out. And maybe it looks like when their CD4 is low, maybe, you don't know why it's missing. They die. People that are dying may not necessarily be healthy enough to be coming in to have it. Maybe I have their CD4 at baseline, and I can use that. That's a not time dependent. But these are time dependent ones. And this is an endogenous one that is related to the event of interest. But my research question is still tied to the event. If I ignore the recurrent things in the middle, that I haven't finished the slides, I was going to erase the orange triangles. My event is still timed to the primary outcome. If I have recurrent events, it's timed to occurrence of events. That's my research question. But now with joint modeling, I'm taking into account those values that are there. Okay. And the incompleteness of values where we have that is what the joint model is handling as well. That's what Dr. Vishali mentioned. But the point is that these are complications because I have designed my study to collect these things because I thought they were important and I want to analyze it. But my research question still is what is the effect of intervention on time to the occurrence of the event of interest or time to the occurrence of events? Make sense? That sort of recaps the whole thing so far. But okay, yes, questions? Um, yeah, I mean, so you would state, I want to show that this intervention works for what? That's the primary thing. Is it work for this outcome? And it's the time to the first occurrence of this outcome, then you don't have to specify anything else. That's the simple thing. If you say, I'm interested in the effect of the intervention on the occurrence of these sets of outcomes, those are the triangles as well as the x's, then yes, you have to specify what they are. So if you're looking at my design of my study is for recurrent events, that's my primary hypothesis is based on recurrent events, then I have to specify what are those events that are recurrent, that I'm interested in. But I don't think anybody has had that the primary analysis is on recurrent events. They've done that as a secondary analysis, but not as the primary analysis of a trial that we've done. Yeah, other people have done that. Yeah, as the primary one. Yeah. Yeah. So if it's as a, so you have to say what is your primary hypothesis, and then design your study for that primary hypothesis. Typically, it is for the first occurrence of some event, whether it's a composite or not, or it is less common recurrent events. With recurrent events, you may get um, events occur frequently, you may get a need for less sample size, but um, that has to be your research case, a different research case. Oh, so if you look at it in retrospect, yeah. He was wanting to design a study. Yeah. The risk, the hazard. Yeah. So you have to have these factors, but to be honest, usually, no. So things will happen. Some people will decide to smoke. Some people will not decide. They'll change their smoking. Some people will reduce. Once they're in a study, they may decide to exercise more. They may decide to do this. They may decide to do that. All sorts of things happen. The longer the study duration, the more things are going to happen. There's more noise that's coming into the system. You will try to have a standard protocol that not only your staff follow, but the patient should follow. It tries to say, don't do this, don't do that, eat this way, eat that way, etc. But again, humans are humans, they'll change. What we tend to do is that large clinical trials will have all of these things that are happening be sort of washed out by randomization. But in small studies, no, right? And so the advice is to measure these things, because then as a secondary analysis, you can see what was the effect of your intervention once I consider all of these things that happen. And they are maybe time-dependent covariates, and maybe baseline covariates. Now you do these secondary analysis to see in an exploratory way what was the impact that these things had on the result that you obtained.
That's a ground. Ethically, it's wrong to look at it.
So, but then let me make a difference in the what is a competing risk versus, yeah, things, everything that we do daily changes our hazard of things, right? So competing event is something that precludes you from observing the other. You're still able to observe the time to the the whatever outcome you have, even if as long as they're not dead, or as long as that, if your outcome was EGFR, but now they're on dialysis, so that everything changes. So then that dialysis is competing for your outcome of EGFR, the change in EGFR. So not competing is not just things that happen to you are not competing. Yeah. Yeah, no, so the thing is, so no, the point is that, the evaluation or analysis of a clinical trial is pretty rigid by regulatory agencies. The reason it's rigid is because people have cheated. People want to show that something works or something doesn't work. They will have looked at the data and changed their outcome and changed their method of analysis and changed this or that. And this is why we now have such regulations. This is why you have to put in the protocol what you're going to do, how you're going to do it, how you're going to analyze things, and register that. And then the regulatory agencies and the journals, the reviewers look at what you said you were going to do and look at what you did in reporting, and they will say yes or no because of what you're doing. So that's why we have to be rigid. So my advice is, in that case, as Dr. Vishali says, when you come to do a trial, you don't do it as your first study. You know a lot about the intervention. You know a lot about things that affect the outcome that you're interested in because you studied this. You know that this intervention has been shown to not be toxic. You know that this intervention administered in this amount of dosing or intensity is going to work because there's been phase 2 studies on this, and you know that's feasible to do. And you or somebody else has done enough prior work before you do a phase 3 trial. And now you're doing this, you have to specify exactly what your outcome is. You have to specify exactly what your intervention is, your control arm, your population. All of these things are exact and you can't change it. You also have to specify how you're going to analyze it. So then what people do is they'll have, there's potential other things that we could do. There are intervening effects that may change the risk. So you could say we will explore this and look at this, but my primary hypothesis continues to be the effect of the intervention on my outcome of interest. You have to also be very careful if it's a study that's going to go to some regulatory agency like the ICMR. Bureaucrats are bureaucrats all over the world. And if you put something down in your protocol or in your study statistical analysis plan that you're going to do this, they will expect that you do that. So exploratory things, sensitivity analysis, be very careful. If you don't put it in your protocol, doesn't mean you cannot do it. But if you put it in your protocol, you have to do it because they will force you to do it. So you can still explore all sorts of stuff. And then you can write secondary papers looking at, oh, now if we looked at all the recurrent events, this is the results that we get. That could be a secondary paper, not your primary paper. People think that do a trial, you have only one paper. No, you have multiple ways of looking at it. Then you can do a joint model with something else, or you can do this, or you can do that. So there's all sorts of things you can explore afterwards. But all of those explorations will always have to keep in mind the intervention. You don't decide to study one arm, for example, because now you're probably in trouble because you have a biased sample there. Okay. All right, enough talking. You guys